Welcome to CrypSwing. This is Aaron Bittman, software developer. You might be familiar with a different version of Crypt that I posted onto GitHub earlier under the simple name Crypt. That version, which I wrote in Python, is my latest and greatest. The year before I wrote that version, though, I wrote my second latest version in Java using swing classes. This version didn't have as many features as my latest one. It simply wasn't as good. However, my reason for writing this version wasn't to build a better mousetrap. I wrote CrypSwing to demonstrate my ability to code in Java and to learn about swing classes. Still, if you're familiar with using my latest version of Crypt, then you should have no trouble using this version, so you shouldn't have to watch this video. If this is your first exposure to my Crypt program, then keep watching. Back in the 20th century, I enjoyed solving cryptograms in magazines like this one. Cryptograms are messages that were encoded with a monoalphabetic substitution cipher. In other words, one letter in the English alphabet would be substituted with another letter or symbol. The message in code is called ciphertext. The plain English to which you translate the encoded message is called plaintext. Of course, solving such problems with only a pencil can sometimes be difficult and tedious. When you guess that a ciphertext symbol represents a certain plaintext letter, you have to search the whole puzzle for all occurrences of that symbol to translate it to the plaintext letter. If you later change your mind, deciding that's not the plaintext letter you want to guess, you have to search the whole puzzle again to erase every occurrence of that plaintext letter you wrote. Obviously, that kind of task screams for a computer program to do the work for you. Furthermore, a computer can quickly search through a dictionary file and suggest to what plaintext words a ciphertext word might translate based on whatever criteria you decide. So when I learn a new programming language and come up with projects for myself to get practice writing in that language, I often choose to write a program to help me solve cryptograms. I typically name this program Crypt, short for cryptogram. In this case, because my purpose was to study swing classes, I called this version CrypSwing. Let's run it. First of all, I'll just mention that if you don't want to bother typing up a whole puzzle on your computer, this program can still help you by searching individual words. You can simply hit the Solve Word button, and you'll get an interface to examine one ciphertext word. I'll explain how to use this window later. But for now, let's go for a whole puzzle. I hit the Populate Puzzle button, and here I type or paste a cryptogram and hit OK. In the main window, you now see the puzzle. Above each ciphertext letter, you see a space into which you can enter a guess at what plaintext letter the ciphertext represents. Notice that the bottom of the window gives us a frequency count of all the ciphertext letters, first in descending order of frequency, and then alphabetically. That can help us make guesses. Let's start by choosing some words. One obvious candidate is this one, PV''A, because it has an apostrophe. Because in cryptograms an apostrophe translates to an apostrophe, I find that words with one often provide a great starting point in solving a puzzle. So I hit the Solve Word button and enter the word. I should explain the like exclusion option. Like exclusion means that a letter cannot translate to itself. For instance, a ciphertext P cannot translate to a plaintext P. Several people have pointed out to me that there's no rule that like exclusion must apply to a cryptogram. However, I've never seen a professionally published cryptogram that didn't have like exclusion, so I see no reason not to check it, especially when it can narrow down the possible answers. When I hit Solve, I get all the candidate words in my dictionary file that fit the pattern. Notice that none of these suggestions start with an A. The single letter word P at the beginning of the puzzle here must be A or I. So PV apostrophe A most likely is either its or it'd, and its is far more likely, so let's guess that. Now, back in the puzzle solver window, notice that when I enter a plain text I over the P is translated to an I all across the puzzle, and so it is for all the other letters. A two-letter word beginning with S is probably so. A four-letter word that starts and ends with T is usually that. The word that gives away the word the. Now, with this many guesses, we can narrow down our search for some other words. Let's open another word solver window. Oh yeah, you can open as many single word solver windows as you want. And compare the results side by side, if that helps you with some puzzles. So let's try this word, AYHOPWZ. Because we're guessing at this plain text, we can narrow down our search with those guesses. Oops. And we hit solve. Of these suggestions, special seems the most likely, so let's try that. My guesses seem to be panning out so far, so let's reuse this window. Let's try this word, YHIAXT. Person seems more likely, so let's try that. The puzzle's almost done. You can easily guess more words yourself, so by now you get the idea. Feel free to peruse my code and feel welcome to give me any feedback on GitHub.